Hey everybody, it's Alex Rutger here. Here to talk about problem 1A for our homework assignment. As you see here, we have my kite ready to go with a rectangle inscribed within it, which was built off of the perpendicular diagonals that we all know that kites have, and then I built the rectangle based off of the midpoint function that GeoGebra has. So, first things first, let's talk about the false conjecture. At first glance, it could seem like our triangles that are created on the outside of the rectangle, that it could seem like maybe there's only the possibility to have a maximum of 2 obtuse triangles there. So, in this current configuration, the 2 apparent obtuse triangles are the 2 congruent ones. Even when we move it a little bit, it becomes apparent that now instead of the congruent triangles, we have the 2 non-congruent triangles that are our 2 obtuse triangles. Now, to prove that this is actually a false conjecture, we can quick slap some angles on these guys. That's an obtuse triangle. That is also an obtuse triangle, and of course the congruent one is also obtuse. So, as it turns out, there is a somewhat small window that allows us to actually have 3 obtuse triangles in this setup. So, there we have the false conjecture that is false. Proven to be false there. So, on to my true conjecture. So, my true conjecture states that the area inside of this rectangle is equal to the 4 areas of the other triangles combined. So, how can I show that this is true? We can use the reflect about a line function. I choose the point on this triangle, I choose this line segment. Noticeably, this point got highlighted. We do the reflect across the line of this point. Here, I think we need to reselect it. And across this side of the rectangle. This isn't working so great. Okay. I think we were just stuck there. Reflect about a line. And see how it highlights it once again for that one. And then we can try it for the 2 side congruent triangles. And it de-highlighted it. That means that it went there again just to signify a change. So then we go one more time on the other congruent triangle, and you might assume correctly that it does work, even though it's not quite showing it here. It does go to this point once again. So why is that so important? Well, that means that there is a reflected triangle on each side of that rectangle, if I were to fill them in. We have now 4 congruent triangles. No, they're not congruent to each other. They're 4 perfectly reflected triangles across each individual edge of the rectangle. And by definition, congruent triangles have equal area. There we have it. Sorry for the slight technical malfunction, but I believe that made it fairly convincing argument. Alright. Hope you found it convincing as well.